You're listening to the N2K Space Network.
And now, a word from our sponsor, SpyCloud, the cybercrime analytics leader. SpyCloud disrupts cybercrime by telling you what criminals know about your business and your customers, so you can take action to prevent ransomware, session hijacking, account takeover, and online fraud. SpyCloud constantly recaptures and analyzes new data from the criminal underground, including credentials, session cookies, and PII siphoned from malware-infected devices. With knowledge of the specific exposed data criminals have in hand from InfoStealer malware on managed and unmanaged devices, security teams can respond with a more efficient and effective process called post-infection remediation that fits seamlessly into existing incident response frameworks. Get SpyCloud's post-infection remediation guide outlining the 7 steps for preventing a malware infection from becoming a full-blown ransomware incident. Visit spycloud.com/cyberwire. That's spycloud.com/cyberwire. And we thank SpyCloud for sponsoring our show.
Only in the world of space nerdery is the news of an open jar accompanied by a picture of dust at all considered exciting, let alone top-level news. But all right, when that dust made a 2-year journey in space to make its way to us from an asteroid, it's certainly some VID, very important dust. And now that the VID has had its red carpet moment with photos galore, as the OSIRIS-REx canister has finally been wrenched open, it's now time to study what's inside.
T-minus 20 seconds to LOS. T-dress to go for deploy. Roger roll.
Today is Monday, January 22nd, 2024. I'm Maria Varmazes, and this is T-minus. NASA finally opens the Bennu sample capsule. Sierra Space tests its first full-scale inflatable space station. JAXA still hopes to power up SLIM. And joining us for our monthly Earth observation chat is Aravind Ravichandran, founder of TerraWatch Space Advisory and Insights. So stay with us for the second half of the show. Let's take a look at our intel briefing for this Monday. It bid farewell to the asteroid Bennu in May 2021, landed back to Earth in September of last year, and now finally, NASA have the OSIRIS-REx capsule fully opened. The team at NASA's Johnson Space Center completed the disassembly of the OSIRIS-REx sampler head to reveal the remainder of the asteroid Bennu sample inside. The capsule had 2 stubborn fasteners that had prevented the final steps of opening the touch-and-go sample acquisition mechanism known as the TAG-SAM head. There's nothing more annoying than a stubborn fastener, huh? Most of the rock samples collected by NASA's OSIRIS-REx mission were retrieved soon after the canister landed in September, but additional materials remained inside the sampler head that proved difficult to access. After months of wrestling with the last 2 of 35 fasteners, scientists in Houston managed to get them dislodged, and they took to the social media platform X to share that it's open, like the new version of Eureka. The post was also accompanied by a photograph of dust and small rocks inside the canister. So what's next? NASA says the curation team will remove the round metal collar and prepare the glove box to transfer the remaining sample from the TAG-SAM head into pie wedge sample trays. These trays will be photographed before the sample is weighed, packaged, and stored at Johnson. The remaining sample material includes dust and rocks up to about 0.4 inches or 1 centimeter in size. The final mass of the sample will be determined in the coming weeks, so we are excited to hear more about what they've found. Moving on to non-dust and rock sample news. Sierra Space has tested its first full-scale expandable space station structure alongside softgoods technology partner ILC Dover. This was the company's first stress test of a full-size inflatable space station structure. The results show that the structure exceeded NASA's recommended safety levels by 27%. The large integrated flexible environment habitat, known as LIFE, is made of expandable softgoods, or woven fabrics that perform like a rigid structure once inflated. LIFE is packed inside a standard 5-meter rocket fairing and inflates to the size of a 3-story apartment building in orbit. The company claims that in just 3 launches, the modular LIFE units can create a living and working environment in space that is larger, volume-wise, than the entire International Space Station. And the video they shared of the test is honestly quite extraordinary, and you can watch it by following the link in our show notes. Redwire has been awarded a contract to develop and deliver 4 roll-out solar array wings known as ROSA, along with multiple Argus cameras and low-voltage distribution units for Blue Origin's multi-orbit space mobility platform, Blue Ring. The ROSA wings being produced for Blue Ring will power the platform for a variety of missions focused on in-space logistics and delivery in medium Earth orbit and beyond. Redwire is also building ROSA wings for the power and propulsion element for the NASA-led Gateway program. The contract amount was not included in the press release. On Friday, we led with the story that was on a lot of people's minds, Japan's slim lunar lander, which successfully touched down on the lunar surface. Unfortunately, as you might know, the vehicle was unable to start up its solar cells and was switched off after 3 hours of operating on battery power. The battery was disconnected with 12% of power remaining in order to avoid a situation where the restart of the lander would be hampered. The Japan Aerospace Exploration Agency, aka JAXA, believes if sunlight hits the moon from the west in the future, there's a possibility of power generation. JAXA said in a statement that they're currently preparing for restoration, and in the meantime, they're carrying out detailed analysis of data acquired during the landing. So what happens to lunar rovers after the countries lose contact with them? Well, it seems that they become a mission in themselves. A laser beam was transmitted and reflected between an orbiting NASA spacecraft and a cookie-sized device on India's Vikram lander on the lunar surface. The successful experiment opens the door to a new style of precisely locating targets on the moon's surface. Sending laser pulses towards an object and measuring how long it takes the light to bounce back is a commonly used way to track the locations of satellites in Earth's orbit from the ground. But scientists say that using the technique in reverse, to send laser pulses from a moving spacecraft to a stationary one to determine its precise location, has actually a lot of applications on the moon. A perfect example of why we should never write off lunar missions that do not completely fulfill their mission objectives as a failure. SpaceX's Dragon crew capsule successfully docked with the International Space Station on Saturday, carrying the first all-European commercial crew. The Axiom 3 4-person crew will stay on the orbiting lab for 2 weeks. Andreas Morgensen, the commander of the station's 7-person Expedition 70 crew, who represents the European Space Agency, said after docking, "This is an incredibly exciting time for human spaceflight with the 3rd private mission, which is allowing many more countries to participate in the scientific research and technology development that we do on board this orbiting laboratory. We have doubled the number of nationalities on board the space station, going from 4 to 8, which I think is a great testament to the international collaboration which underpins this marvelous space station. Hear, hear." Iran's state media has reported that the country has successfully conducted a satellite launch into its highest orbit yet. The Soraya satellite was placed in an orbit at some 460 miles above the Earth's surface with a 3-stage rocket, according to the state-run IRNA news agency. No information was provided on the satellite's mission, and the West has not independently verified the claims. A team at the UK's University of Surrey is helping to build a fuel gauge that will be tested aboard the International Space Station to measure how full a tank is in zero gravity by using electrical sensors. The Smart Tank for Space, aka SMARTS, is being developed by ATOUT Process Limited. The company has enlisted the help of space engineers at the university's Surrey Space Center, and it will use facilities available at the site. And that wraps up our briefing for today. You'll find links to further reading on all the stories we've mentioned in our show notes. Added to the stories today is a piece on Relativity Space's plans to build a new tower at Long Beach Airport, and a piece from a space policy official detailing the approach to maintaining the U.S. edge. They can also be found on our website at space.n2k.com and by just clicking on this episode title. Hey T-Minus crew, every Monday we produce a written intelligence roundup, and it's called Signals and Space. So if you happen to miss any T-Minus episodes, this strategic intelligence product will get you up to speed in the fastest way possible. It's all signal, no noise. You can sign up for Signals and Space in our show notes or at space.n2k.com.
And now a word from our sponsor, 6 Sense. 6 Sense provides award-winning cloud-based automated endpoint and vulnerability management solutions to streamline IT and security operations. With its advanced platform, businesses gain complete visibility and control over their infrastructure, reducing IT and security risks and optimizing operational efficiency. With 6 Sense, you'll get real-time alerts, risk-based vulnerability prioritization and remediations, and an intuitive automation and orchestration engine so you can focus on your core business goals, confident in the knowledge that your enterprise is secure, compliant, and running smoothly. Visit 6sense.com to learn why enterprises choose them.
Joining us for our monthly Earth observation chat is Aravind Ravichandran, founder of TerraWatch Space Advisory and Insights.
Government, we can probably start there, is still going to remain the key player in the evolution of the Earth observation market. I think that's not going away. There's not going to be the sovereign Earth observation constellation. That is not going to go away because countries are still becoming very interested in launching their own assets. So data independence becomes more important, and also just kind of the way the world is evolving geopolitically, but also, from a climate perspective. So I think a lot of countries are interested there. And the third part is more what's going on in the Earth observation sector with respect to funding. Funding for that went down compared to 2022. But then what went up was funding for more application companies. So companies that are using EO data to develop products that are specific for a specific market or, a specific vertical. So I think funding for that is going up or gone up last year. And I kind of expect both of these to continue. Satellite data companies are going to find it hard to raise money just because of, what the macroeconomic situation looks like. But also, the Earth observation market has been on a bit of an upswing for the last 3-4 years.
Yeah, so potentially a bright spot.
Yeah, I think the good thing is the validity of a lot of Earth observation technologies and use cases is going to happen this year, which is something really to look forward to because we've been really in a lot of a hype game where EO is useful for this, EO is useful for that. And I think we probably talked about it in one of the episodes previously about what do people want to really pay for versus what is the open data that's already available good enough. I think that validity is going to come, and I think it's only going to be good for the market because at least we can go on and focus on doing things that actually add value, because there are some where we know that will happen is there are going to be some sensors, there are going to be some use cases for which we'll realize that, okay, commercial data is not as promising as we thought it's going to be. Open data is going to be good enough. Whereas others, we're going to realize that, for example, take insurance or take financial services for climate risk or for, obviously from an agriculture point of view or for wildfires. So you're going to realize that, okay, commercial data has a lot of value because if this data is not available, companies are going to lose a lot of money. Insurance companies are going to lose a lot of money. Governments are going to have a lot of damages. So there are some for which we will get more validation for commercial data, which is also a very good thing. So in a sense, it's not a bad thing that some companies might not raise as much money, or some companies or some sensors or some technologies might not see a lot of value. I think that's just inevitable. But I think the good thing for that is we can actually go on and move on to the operational phase where we know that this is what they require, and then we can actually go on and get into the boring phase of things just working normally. Data is downlinked and they process it, and then they get the analytics, and then that continues, right? Like just like how good example of weather still works. Satellites get launched. Nobody even talks about whether it's as kind of
it's so status quo. Yeah,
it's embedded. Yeah. It's embedded.
Yeah.
I mean, still there's a lot of gaps to fill in different parts of the world. It's not a solved problem, but at least the kind of the end-to-end workflow is figured out. And even if a commercial company like Spire, we had news from Spire about them getting or continuing to get a NOAA contract recently. So Spire gets a contract, and their data is integrated into the larger weather processing system from NOAA, and it goes on like it may be news, but it's not like huge news like, oh, there's a new technology. So I think that's the stage we're going to have to get to in Earth observation quite soon, because we've been in, it's useful for this, it's useful for that phase. But now we're going to get to a actual operational phase where it just continues to be used.
Consolidation seems to be a word that has come up a lot when people are looking ahead this year. And I noticed you use that quite a bit as well. Thoughts on that? I mean, do you feel like we've covered that, or what are your thoughts?
I think it's important to realize that consolidation will be horizontal and vertical. So horizontal in the sense, sensor companies realizing that they may need another sensor. So, this company maybe is struggling to raise money or is probably not gotten product market fit because it's better suited with the sensor from another company. So they can realize and they can kind of, get together. Or it can be a company that, that we kind of saw that from end of last year, when Hawkeye 360 bought the RF monitoring unit from Maxar and integrated into them. Hawkeye is an RF company, so they realized that, their RF capabilities actually work alongside with us. So, we kind of joined hands and they acquired that unit. But the horizontal can also be companies just going down the value chain. Last year, we also saw Planet acquiring Synergize. So, it's where Planet, which was a data company, now acquiring another company, which is doing platforms to do a bit of both data and platform. So I think that's horizontal. But then consolidation can also be vertical, right? Like, so you can have an insurance company who realizes that this technology or this product is super useful for us. So we're going to go and, acquire or partner with a company who is very much focused on solving one specific problem. And we saw that again with the insurance company called Swiss Re, acquiring a small startup from the UK who were doing flood mapping and kind of long-term flood risk. And I thought that was interesting because they are not kind of acquiring a company that's launching satellites, but then they're acquiring a company that is using derived products from satellites. So I think that's kind of how adoption is going to go. And I think consolidation is going to happen on both fronts.
That'll be fascinating to see that happen. So keep our antenna up for that one. Okay, so I wanted to switch topics. Pulling out from your newsletter, you had an interesting tidbit in here. I'll read it back for our listeners if they haven't read it. You wrote that NASA is making progress on a multi-billion-dollar series of Earth science missions amid uncertainty about their funding for the next year. And you wrote a comment that I wanted to have some elaboration from you on this because I thought this was fascinating. You wrote that, I am worried that we're heading towards a future in which societally important Earth observation satellites with advanced scientific instruments will fight for the same pie of public funding as economically important sovereign EO satellite constellations with redundant data capabilities. So I would love to just hear some more about that because that really intrigued me.
Yeah, it's again, one of the more opinionated kind of takes is obviously, as I mentioned, before, a lot of countries are involved in launching their own satellite constellations. And I think it's important to realize that we don't have unlimited budgets for Earth observation. So if you look at a country, what it decides to put the money in from an observation point of view can be, we're going to launch a few satellites because we want independent capabilities, but that satellites may not be scientifically advanced. They may not do anything that is groundbreaking, that is actually, pushing the barrier in terms of what we can do from satellites and from space. But it's a redundant capability. Not everybody is doing that, but I was just saying that I'm worried because I know for a fact that funding is not unlimited. So if NASA decides to, go on with that mission, and I think it applies to NASA as well, but NASA is not trying to go in that respect because NASA is kind of an advanced space nation. But then we have a lot of emerging space nations coming up, and it was not meant to kind of point fingers that nobody is kind of looking at science, but it's just looking at the reality of the situation. So if you're an emerging space nation, why shouldn't you have your own satellite constellation? Absolutely, you can. And you may not have a lot of funding, so you may just go for a technically redundant capability, right? Like I need to be self-sufficient for monitoring my borders, so I'll just do exactly what's needed for that. So you're not going to put in your money for, I don't know, monitoring sea ice more frequently or for understanding emissions better. You can also do that, but then you just chose to do the other thing, also very understandably. But what the worry is there's not a lot of money, and we need to use the money we have properly. And NASA does have budgetary issues with what's going to happen with the next year's funding, the US for federal funding. So we're going to have to wait and watch what happens to the future missions, because we have to keep in mind that they are all missions that are kind of recommendations by what is called the Decadal Survey, where we look at what are the things that we are not observing in the world, and they do that stock take every 10 years, Decadal Survey. And we figure out that these are gaps that we need to fill in order for us to understand something better. And that's how these missions are formed. They are not coming out of the blue. They are formed from, we are not monitoring these, and we need to really monitor them for understanding climate, understanding something on the scientific front. So if these missions are not implemented, we may actually have gaps that, we are not filling in terms of, either observing something that we need to in order to progress on climate science or progress on a lot of things, right? Like it goes back to the conversation about how much are we willing to invest in science and what is the price we have to pay.
Aravind, I know every month we do a checkup, and I was noticing on your LinkedIn that you've got an event that you're promoting, and I thought maybe you wanted to tell the audience a bit about that.
Yeah, I think the event's kind of light. It's been in the making for the last 3 to 4 months. So it's called EO Summit. It's happening in London, mid-June, June 13 and 14. The aim is to organize a conference that is specifically focused on Earth observation, but with kind of two, let's say, underlying principles. One being it is user-focused. So it's not a conference where there's going to be a lot of just people from the same space bubble or the Earth observation bubble. There's going to be a minimum of 1/3 of attendees who are going to be users. So people who are using Earth observation across 4 tracks. There are 4 tracks in the conference, like insurance, finance, energy, infrastructure, utilities, agriculture, forestry, and climate. So kind of all of the commercial, non-defense use cases. And the second principle is more to be application-driven. So instead of talking about what SAR can do, what hyperspectral can do, we're going to focus on like a few set of selected applications, like, what is Earth observation doing for claims and underwriting in the insurance world? What is it doing for commodity trading in the finance world? Or what is it doing for crop monitoring or carbon markets? So, a lot of application-driven focused sessions where, the audience and also kind of, anyone who's interested can just understand really who's doing what, because a bunch of users are going to come and present as opposed to Earth observation people. Earth observation people can obviously present case studies of this is how our data is used, etc. But then more importantly, there's going to be a lot of user perspective. So a user who's using EO to, from an energy company or an insurance company or, in any of the sectors that I just mentioned, talking about how they use it, what are the challenges, will they use commercial data or just using open data is good for them, those kind of conversations.
We'll be right back.
Now, a word from our sponsor, the Johns Hopkins University Information Security Institute, currently seeking qualified applicants for its innovative Master of Science in Security Informatics degree program. Study alongside world-class interdisciplinary experts and gain unparalleled educational, research, and professional experience in information security and assurance. Interested U.S. citizens should consider the National Science Foundation's CyberCore Scholarship for Service program, which covers tuition and a $6,000 annual professional development allowance, as well as providing a $37,000 additional annual stipend. Apply for the scholarship and the fall semester by March 1st. Learn more at cs.jhu.edu/MSSI.
Welcome back. And we're finishing with a story today that warms my Trekkie heart. NASA's Curiosity rover has recently sent an image back to Earth of the Mars terrain, and one or many eagle-eyed fans spotted a symbol that definitely resembles a Starfleet Delta insignia. Eat your heart out, Giovanni Schiaparelli. We're evolved from seeing canals on Mars to comm badges. Okay, the comm badge, or the rock-shaped like one anyway, was spotted in an image from Curiosity's left navigation camera as it navigated Aeolus Mons on Sol 4062 of Curiosity's mission, which in Earth time would be January 9th. There's a whole Twitter feed, or X feed, that uploads raw images from Curiosity pretty much as soon as they come in. And this might surprise you to hear, but many people who keep an eye on images from Mars are also Trekkies. I know, shocker. Anyway, lots of people instantly recognize the Starfleet Delta in the wind and water-swept rocks. It's not even a stretch, honestly. It really does look quite like a shield delta. Coincidence? Well, maybe. Wouldn't we all like to believe that it's a misplaced comm badge, perhaps left behind by a distracted away team member? Well, humanity is still a pre-warp technology for now anyway. So this would be a violation of the Prime Directive, would it not? Well, not like they don't break that rule every other day. That's it for T-Minus for January 22nd, 2024. For additional resources from today's report, check out our show notes at space.n2k.com. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. And we're privileged that N2K and podcasts like T-Minus are part of the daily routine of many of the most influential leaders and operators in the public and private sector. From the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K Strategic Workforce Intelligence optimizes the value of your biggest investment, your people. We make you smarter about your team while making your team smarter. Learn more at n2k.com. This episode was produced by Alice Carruth. Mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Jen Iben. Our VP is Brandon Karpf. And I'm Maria Varmazes. Thanks for listening. We'll see you tomorrow.